the algebraic law of a set, which is also known as the properties of a set. So let's talk about these laws one after the other. So the first one we're going to be starting with is known as the idempotent laws. So this law states that if A is a set, then A union A is simply equals to A. So now we won't just be writing this law, but we are going to be looking into it, if at all it is true or not. Now let's say A is a set and it includes elements 1, 2, 3. Now A union A, will it be equals to A or not? So what will be the value of A union A? So the set of A union A will be equals to a set that consists of elements in A, either A or A. So it's still going to be 1, 2, 3. So therefore, this law is true, okay, for all cases. So now the second one, it says A intersection A is also A for the idempotent, okay? So A intersection A is also A, okay? So therefore, if A is a set and it includes elements 1, 2, 3, 1, 2, 3, therefore A intersection A will be equals to 1, 2, 3 as well, okay? So hopefully you guys are following. So it means this law is true for all cases. Now let's move to the second law. This is known as the commutative law, okay? So this one is idempotent. So I will be denoting this with capital letter I, okay? Okay, now the next one is commutative. So let me denote that with C. Okay, now this law says that if A is a set, B is also a set, then A union B is equal to B union A. What are we saying? It says if A is a set and B is also a set, then A union B is equal to B union A. Also, it says I made a mistake. Is equal to B union A. And it also says that A intersection B is equal to B intersection A. Excuse me. Now let's try to make use of this using an example. So if A is a set, so let's say A is a set and it consists of elements 1, 2, 3, okay, and B is a set and it consists of elements 2, 4, 6. So A union B is equal to what? A union B is equal to 1, 2, 3, 4, 6. Now B union A will also be equals to 1, 2, 3, 4, 6. So therefore they are equal. Okay, so it means this is true. Okay, now let's try to work out an example using the second rule as well, or second law. Okay, so we said A intersection B will be equals to what? What is the intersection? 2. Okay, B intersection A will also be equals to 2. So therefore this is also equal. So that is an example using the commutative law. Okay, so hopefully you guys are following. So now let's move to the next one, which is known as the associative law. Okay, I don't know if this place is going to be enough. Maybe I just adjust this a little bit to closer to the idempotent. Okay, as you may know this way. So let's move to the third one. We said it is commutative law, or associative rather. Okay, now for associative law, I'll be denoting that with capital letter A. So associative says that A union B union C is equal to A union B union C. That is, if you have A union B, A union B in bracket, okay, union C, we said this is simply equals to A union B union C. Okay, so hopefully you guys can figure it out. Okay, I'm just trying to manage the space, and it also says that A intersect B intersect C. Okay, A intersect B intersect C is also equals to A intersect B intersect C. Now let's check this using some formula, some examples. Okay, now let's say A is a set and it consists of elements 1, 2, 3. B is a set and it consists of elements 2, 4, 6. Then C is a set and it consists of elements 1, 3, 5, 7. Okay, now what will be the value of A union B union C? Okay, now A union B, we need to find the value of A union B first. Okay, now A union B is simply equals to what? A union B is equal to 1, 2, 3, 4, and 6. Therefore, A union B union C will be equals to what? 1, 2, 3, 4, 5, 6, and 7. Okay, now let's find A union B union C. Okay, so we need to find the value of B first. So hopefully you guys have written the idempotent and commutative. So because I need to rub it up now. Okay, so if you haven't written it, feel free to pause the video and write it down now. Okay, so we need to find B union C. So B union C will be equals to what? So B union C will be 1, 2, 3, 4, 5, 6, 7. Okay, this will be 1, 2, 3, 4, 5, 6, 7. All right, now A union B union C will now be equals to what? 1, 2, 3, 4, 5, 6, 7. Now the fact that this and these are the same. So therefore, the law is true for the first case. So now let's try to check out the second case. So for the second case, we said A intersect B intersect C is equal to A intersect B intersect C. So therefore, we are going to have A intersect B to be equals to what? What is the common element between A and B? So I think it's 2. Only 2 are the common element. So therefore, we are going to have 2 as the intercept of A and B. And therefore, A intersect B intersect C will be equals to what? Now, the fact that there is no any common element between A intersect B and C, okay, therefore it will be empty set, okay, it will be empty set. So we denote empty set with empty brackets or something like this, okay. Now let's move on to the second case. We said we are going to have A intersect B intersect C. So we need to find B intersect C first. So what's B intersect C? This is simply equals to what? This is B, this is C. Is there any common element between B and C? 1, 3, 5, 2, 4, 6. There is not. So it is an empty set. Okay. Now A intersect B intersect C will now be equals to what? Since there is no any common, then it's still going to be an empty set. So therefore, the fact that this is empty set and this is also empty set, so therefore the law is true for the both cases. Okay, so now let's move to the next one, which is known as the distributive law. Now for this law, it says that, let me denote it with capital letter D. Okay, A union B intersect C is equal to A union B intersect A union C, and A intersect B union C is equal to A intersect B union A intersect C. A intersect C. Okay. Now let's try to show this using some examples. So let's say A is a set and it includes elements 1, 2, 3, 4, 5. And B is also a set and it includes elements 2, 4, 6, 8. And C is a set and it includes elements 1, 3, 5, 7. Okay. Now let's go ahead and provide the solution to the first cases, the first law. Okay, we need to find what we call B intersection C first. Okay, so B intersection C is what? B intersection C is equal to what? What are the elements in B intersection C? So let's go ahead and check it out. 4 is here, 4 is here, 2 is here, 2 is here. Okay, so therefore we have 2 and 4 as the intersection. We have 2, 4. Okay, now therefore A union B intersection C will now be equals to what? This will be simply equals to this B intersection C. This I guess I've made a mistake. Okay, B intersection C is this set and this set, not this and this. Okay, so we need to correct our mistake. Okay, so this is B, this is C. So B intersection C will be what? Element in common between B and C. And there's no any common element between them, so it will be an empty set. Okay, so it will be an empty set. Now A union B intersection C will now be equals to what? Now we want all the elements in B intersection C and A, so this will simply equals to 1, 2, 3, 4, 5. Okay, so that is A union B intersection C. So let's go ahead and provide the elements in this and check it out if they are going to be the same or not. A union B, it will be what? A union B is what? What are the elements in A union B? That's 1, 2, 3, 4, 5, 6, then 8. Okay, now what about A union C? A union C will be equals to what? To be equals to 1, 2, 3, 4, 5, and 7. Okay, for the sake of those who might be wondering how I got A union B, okay, I just combined the elements in set A and set B. Okay, and now I got A union C, I just combined the elements in set A and set C. Okay, now let's move on. We want to find A union B intersect A union C. Now what will be the value of A union B intersect A union C? So therefore A union B intersect A union C will be equals to the intercept of what? Of this and this, that is the common element between them. Now what are the common elements between them? 1 is common, 2 is common, 3 is common, okay, 4 is common, 5 is common, it's sub of 5. Okay, those are the common values. Okay, so therefore we have A union B intersection A union C to be equal to 1, 2, 3, 4, 5. Okay, so the fact that this and this turns out to be the same, then the equation or the law is true in the first cases. Okay, so now let's try to check out the second case. So for the second case, we said A intersection B union C is equal to A intersection B union B A intersection C. So let's try to find B union C first. Okay, what will be the value of B union C? B union C is equal to what? What are the elements in B union C? So these are 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so these are the elements in B union C. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now what will now be the value in A intersection B union C? What will be the element in it? Okay, now it turns out that element 1, 2, 3, 4, 5 turns out to occur in the whole set A. So therefore all these elements are said to be their intersection. Okay, because they are common in both of them. It's going to be 1, 2, 3, 4, 5. Okay, Now let's move to this point. What will be the value of this? A intersection B union A intersection C. Let's find A intersection B first. What is the value of A intersection B? So A intersection B is equal to what? What are the elements in it? So to be, this is A, this is B, okay? So we have 2 to be common and 4 to be common. So we have 2, and 4. That's for A intersection B. What about A intersection C? A intersection C, okay? What are the elements in common in A intersection C? So this B, this A rather, this C. So we have 1 to be common, right? We also have 5 to be common, okay? And 3 is also common as well, both of them. So therefore their intersection will be 1, 3, 5. So that's 1, 3, 5. Okay. Now, what will be the value of A intersection B union A intersection C? So let's go ahead and provide the solution to that. Okay. So therefore, A intersection B union A intersection C. Okay. Union A intersection C will be equals to 1. We just need to combine the element over here. Okay. 1, 2, 3, 4, and 5. So this should be the intersection. Okay. This will be the intersection union of both of them. Now the fact that this and this are the same, so therefore the law is true, or the equation is true for all cases as well. So let's go ahead and move to the next one, and this is known as what? The identity law. Okay. So this law says that if A denotes a set and we have an empty set, okay, so A union empty set is simply equals to A, and also A intercept empty set is simply equals to empty set. Okay, and at the same time, this law says that A intercept the universal set is simply equals to A, and A union the universal set is simply equals to the universal set. Okay, now let's try to check these equations out one after the other. Okay, now for the first one, which is this, okay, we will observe that without even putting anything in example in order to show it, then the equation is true, because A union empty set will also be A, because we said empty set is a subset of all sets. Okay, now if we are to find their union, just combine them together, then the result is going to be A. Okay, now for the second one as well, we said A intersect empty set. Now we said empty set is a subset of all sets, right? Now if you have empty set, let's say A is a set. Let me try to show it out. If A is a set, so this is 2. If A is a set, it includes elements 1, 2, 3. Okay, and we have empty set. Let's say B is an empty set. Okay. Okay, so what will be A intersection B? A intersection B will be equals to empty set. A intersection B will be equals to empty set. Why? Because this set A also include an empty set, because empty set is a subset of all sets. If you are to list out all the subsets in this set A now, then we have to include the empty set and the set itself. So therefore the intersection between A and B will be an empty set. So that's how these equations comes. Okay, so this is also true as well. So we are dealing with what? The identity law. Okay, Now for the third one, it says A intersection universal set is A. So let's try to check that out. So if the universal set is a set that consists of elements from 1 all the way to 10, and A is a set or subset of the universal set, and it consists of elements 1, 2, 3, 4. A intersection universal set will be what? Now it turns out that intersection means the elements that are common in both the particular sets. So 1, 2, 3, 4 is in set A. 1, 2, 3, 4 is also in set of the universal set. So therefore, A intersection universal set is equal to 1, 2, 3, 4. And these 1, 2, 3, 4s are elements in set A. So that's how this is being derived. So A intersection universal set is still the particular set A. Okay. Now for the last one, which says A union universal set is a universal set. Okay. Now we said universal set should be 1 to 10, and A should be 1, 2, 3, 4. Now what's their union? A union universal set will be equals to the element in either A or the universal set. Okay. Just combine them together. Now we have 1, 2, all the way to 10 as their union, and these particular elements are the elements in the universal set. So that's how this is being derived as well. So therefore all these laws are true for in all cases. Okay, now without any further ado, let's move right into the next one, which is known as the complement law. So the complement law says that if we have A to be a set, then A union A complement is equal to the universal set. Okay, let me use the new sign. Okay, now it also says that A intercept A complement is equal to empty set, and A complement raised to A complement is equal to A, and at the same time E complement, that is universal complement, is equal to empty set, and empty set complement is equal to a universal set. Okay, so that's the basic laws behind complement laws. So let's look into this one after the other. So for the first one, we said A union A complement is the universal set. Okay, now let's say the universal set U, okay, consists of elements 1 all the way to 10. 1 all the way to 10. Okay, and set A consists of elements 1, 2, 3, 4. Okay, now what will be the value of A complement? So A complement will simply be equals to the set that consists of elements in the universal set that are not in set A. So what are these elements? So that's 5, 6, 7, 8, 9, and 10. Okay, now what will be the value of A union A complement? So the fact that A union A complement will consist of elements that is what? That is either in set A or in set A complement. So we are combining them together. 1, 2, 3. We observe that as we keep going, we are still going to reach 10. And the element we have here is the element we have in the universal set. So therefore, the statement or the law is true in the first case. Okay. Now for the second case, we said A intercept A complement is equal to empty set. What is the value of A intercept A complement? So A intercept A complement will be equals to what? So A intercept A complement. Is there any common element between the set A and the complement. Now the fact that there's no any common element between them, then it's going to be an empty set. So this one is true as well. Okay. Now the next one is that a complement raised to a complement is simply equals to a. A complement, we said, is 5, 6, 7, 8, 9, 10. Now we want to raise this as a complement as well. A complement, okay, to a complement. So this simply means elements that are in the universal set, okay, but not in the A complement. So please, do you guys get it? Elements that are in the universal set but not in the A complement. So this simply equals to a set that includes elements 1, 2, 3, 4. And this element we have is simply the same as the element we have in set A. So that is how this becomes set A as well. So this is also true. So let's go ahead and move to the next one, which says U complement is equal to the empty set. Okay, so U complement means elements that are not in the universal set. Okay, so the fact that we don't want element in the universal set, then we are not going to be left with any other thing left. So that's how we got the U complements to be an empty set. So this is also true. Now the last one is that empty set prime. This will simply equals to the universal set, because if you what it really means is that elements that are not in empty set but in the universal set. So it's going to be all the elements. So therefore, the result is going to be the universal set. So this is also true as well. So let's move to the second to the last rule or law, which is known as De Morgan's law. Now, what is this law? What does it say? Okay. So it says that if we have A union B in the parentheses raised to the complement of prime, okay, this simply equals to A prime union B prime. Also, if we have A intersection B, okay, prime or complement, this simply equals to A complement, okay, intersection B complement. Okay, I would even like to say there's no need of making use of example to check or to show if this is simply correct or not. This is simply right or not, because you can still make use of some algebra at this point, okay, by just distributing this for distributing what we have outside for everything we have inside, okay, but not in that case. Let's try to check it out using some examples. Okay, so let's say A is a set and it's include 1, 2, 3. I'll make it short. Okay, then B is also a set and it's include 2, 4, 6. So A, the universal set is a set that include 1, 2, 3, 4, 5, 6, 7. Okay, now what will be the value of A union B prime? So A union B prime, A union B complement will be equals to what? I need to adjust this a little bit because I don't know if this space is going to be enough or not. Let me just adjust it. So A union B prime will be equals to what? Elements in A union B that are not in the universal set. Elements in the universal set that are not in A union B. We haven't even find A union B. Let's find A union B. A union B will be equals to 1, 2, 3, 4, 6. Okay, so the prime becomes what? 1, 2, 3, 4, 6. So it means it's going to be left with 5 and 7. So A union B complement is 5 and 7. Okay, now let's find A prime. What's the value of A prime? So A prime will be equals to what? Elements that are in the universal set but not in set A. So we have 1, 2, 3 alone in set A. So we are going to be left with 4, 5, 6, 7. We have 4, 5, 6, 7 as A complement. Now, what about B complement? B complement will consist of elements in the universal set, but not in set B. So we are going to be left with 1, okay, 3, 5, okay, and 7. Okay. Now, what is their union? Okay, we want to combine both of them together. So their union becomes what? So A prime union B prime will be equals to 1, 3, 4, 5, 6, 7. Okay. So I guess there is a mistake. Okay. So it should be from the formula, I guess. It is A union B prime is equal to A prime intersection B prime. Okay, sorry for that. Nobody above that. So this will also be union. Okay, so this will be intercept, and this will be union. Okay, so therefore we are finding the intercept, not union. Okay. So A prime intercept B prime will be equals to what? This will be simply equals to this is A prime, this is B prime. What do we have in common between them? So that should be 5, 5, then 7, 7. So these are the common elements between them. So therefore we have 5 and 7. Okay, so the fact that these and these are the same, then the equation is 2 in the first cases. Okay, it's 2 for all cases using the first law. Now let's try to check the second one as well. Okay. So it says that A intersection B prime is equal to A complement union B complement. So let's try to check it out. Let's find A intersection B. What is the value of A intersection B? So this simply equals to what? This is A, this is B. We have 2 alone to be their common element. Okay. Now, what is the complement of this? A intersection B complement. So this will be simply equals to the element in the universal set, but not in A intersection B. So this simply equals to 1, 3, 4, 5, 6, 7. Okay. Now let's move back to this point. Okay. Now what is A prime? A prime or A complement is simply equals to elements that are not in set A but in the universal set. Okay. So that should be what? That should be 4, okay, 5, 6, 7. Okay. Now B prime is elements that are not in set B but in the universal set. So that should be 1, okay, 3, 5, 7, 8. Okay. Now what is the value of A prime union B prime? So we need A prime union B prime. So this simply equals to 1, okay, 3, 4, 5, okay, 6, then 7, okay, and what? And yes, that's all. So there's no 8 here. Okay, it is not here. Okay, so the fact that this and this are the same, so therefore the law is true for all cases. Okay, now let's talk about the last one. The last one is known as the absorption law. Okay, so I'm using the last one as an exercise for you guys So I want you guys to make use of it and show it using some particular set. So denote A as a set and give it some amount of elements, denote B as a set and give it some amount of elements. Now use this element or set to show that this law is true for all cases. Okay, you can comment your answer in the comment section below in order to review it. So what exactly is this law? It says that if A is a set, then A union A intersection B is equal to A, and if A is also a set, A intercept A union B is equal to A. Okay, so if you haven't subscribed, make sure you subscribe now. Okay, so thanks for watching my video. See you guys in the next video. So if you want me to review like I just said, you can comment your answer in the comment section below, then I will review it and reply to it as earlier as possible. So see you guys in the next video. Thanks for watching once again.